A moment ago, we solved this quadratic equation by creating a perfect square. We created our own situation that would let us create a perfect square and then take the square root of both sides with a plus or minus. And the solutions we got were -5 plus I and -5 minus I. If you want to go back and watch that video and remind yourself how it was done, you should. But we're going to talk about how to verify and prove that this is in fact the answer that we thought it was. If this is true, we should be able to plug it back in and find that 0 equals 0, exactly what we were looking for. So I can have -5 plus I squared plus 10 times -5 plus I plus 26, and that should equal 0. All right, this is going to involve some work that I could do in my head, but because I've noticed that it can be frustrating to follow, I'm actually going to write it out. So -5 plus I squared is -5 plus I times -5 plus I, and -5 times -5 is a positive 25, and then a -5 times a positive I is a -5I, and a -5 times a positive I is another -5I, and a positive I plus times a positive I is a positive I squared. Then this next term, the 10 times -5 plus I, that's going to become -50 plus 10I. And then this last term, the 26, is unmodified. Who cares? Equals 0. Then I can start doing some combining of like terms. Let me just bring this down to be clear and consistent with my work. Now I can start combining like terms and replacing things that are interesting to me. So 25 minus 50 is going to be 25 minus 50 is -25. Oh, plus a 26. Okay. And -5 and -5 is going to be -10I. Oh, and then there's a positive 10I. So I've handled that. I handled the 26 already. And the only thing left I have to handle is this I squared term. And I squared is the same as -1. And if we've got this right, this whole thing should equal 0. So -25 plus 26 is going to be +1. -10I plus 10I is going to be 0I. So these terms mutually annihilate. And then plus -1 is just -1 equals 0. +1 minus 1 equals 0. 0 does in fact equal 0, which means the solution we found using our tricky completing the square method, if we plug it back in and go through all that work, does in fact give us the exact answer that we thought it would.